Hello again, this is Andy Pils. It is Unit 8, Day 8, and in today's video, I'm going to be walking you through this hurricane strength module. Now it says that it should take you about 45 minutes, so I'll make a quick video going over the individual parts, but if you're following along with me, I would suggest pausing it and making sure that you answer all of the questions and do all of the work that you need to do before continuing on to the next section. So here we go. In this activity, you will use the Hurricane Explorer to investigate the factors that influence hurricane strength. You will explore seasonal effects on hurricane formation, growth, and movement. You will also begin to draw parallels between rising trends in sea surface temperature and the frequency of high-intensity hurricanes. So here we go. We're going to start off just by looking at the different categories of hurricane. Again, I would pause this video and kind of read through this information, but this section is going to go over how we determine hurricane category strength, which is based on wind, and then there's a couple questions to answer based on that information. Section 2 is fuel for a storm, where we're going to be investigating how sea surface temperatures affect hurricane strength. So our instructions here say, in order to investigate the sea surface temperature of the model, click Map Overlays and then Sea Surface Temperature. And we can use the orange season button at the bottom to change the seasons. Notice the change in sea surface temperature. Run the model in each season to see what happens. Let's scroll down here. And one thing to remember is that water has a much higher specific heat than land. So even though in the wintertime we are getting the least amount of insolation and we're getting the shortest days, we'll feel cooler atmospheric temperatures on land, but the water is going to take a longer time to cool down. So in the winter, we'll still see a tropical storm possibly forming here in the Atlantic Ocean. And as we get that decreased amount of insolation, and the days go by, as it turns to spring, we'll actually see even cooler water temperatures. Even though the air temperature is warming up and we're getting longer days, it's going to take a lot of energy to change the temperature of the water, and therefore spring is actually going to be the coolest month. And we see that as we go from spring to summer. Again, even though we have the hottest air temperatures and we're receiving the most insolation in the summer, we'll see even warmer temperatures in the fall, and then it decreases again in the winter. So we can run the model and see what happens. We know that in the winter, we'll still get some tropical storms. We saw that before. In the springtime, when we have the coolest temperatures, sea surface temperatures, we barely get any tropical storms forming because they don't have that fuel to make that storm continue to get bigger. Our hurricane season does start in the summertime. That's when we're going to start to see the sea surface temperatures increasing a little bit. So we'll see this normal storm track. We have a Hurricane 1, just a little bit of hurricane, Category 2 hurricane, but we'll see our most intense hurricanes happening here in the fall. We get up to Category 1, 2, the wind speeds are going to increase even more, about a Category 4. And once it either heads north to the cooler temperatured oceans or once it makes landfall, we're going to see a big decrease because there's no more warm, moist air rising and fueling that hurricane. Before we leave here, there's a couple questions to answer. So go ahead and answer those based on the work that we just did, and then we are going to continue to section 3, which is, do hurricanes happen all year? So again, we're going to be looking at seasons, which seasons are more likely to have strong hurricanes. I think I may have gotten a little bit too excited and already explained that. So we'll go ahead and answer these questions. I'll make sure that there's nothing else I need to cover, and then we'll move on to the next section. Just one more thing to note with this interactive before we go into the future sections is the wind direction. So remember that high pressure and low pressure systems are going to influence where this storm goes. So the air around a high pressure system is going to go clockwise, and around a low pressure system, we're going to see it moving counterclockwise. It'll actually move out in clockwise at a high pressure area and in counterclockwise at a low pressure area. So I always like to remind my students the clock is high and the counter is low, to remember that. And the more time that this tropical storm or hurricane spends in the warm oceans, the more fuel it's going to be added and the higher wind speeds we're going to see. So if we take the season where we have the warmest sea surface temperatures, and I move these pressure zones around a little bit to influence the way that the storm moves, if I have the storm spend more time in those warmer temperatures, then it's possible for that wind speed to increase, and therefore the category of the hurricane increase. So there it is, category 1, 2, 3, 4. Didn't get there that time. Let's see if I can get it this time. I'm going to move it a little bit more. Let's see if I can get some rotation counterclockwise around that low pressure area. Let's see. It's going to move over the highest temperatures of the ocean over here. Category 4. I'm going to keep on finagling with this, but you can do that too. Let's move on to the next sections to take a look at how this connects to climate change. Section 4 is a video on how hurricanes form. So in this, you're going to see how they form, as well as what processes are going to happen in order to fuel those hurricanes, build up those wind speeds, and potentially cause a lot of destruction to our communities. In section 5, we're going to start taking a look at long-term data. So remember, weather is short-term. The climate is going to be looking at long-term data. So when we're looking at this data table, we're going to see every 5 years how many hurricanes are happening in the Atlantic Basin. And the questions here are going to ask that you analyze this data. So just overall, if we were to look at it, first off, we see 3 color-coded values for these bars. So gray is going to be tropical storms, orange is hurricanes, and red is going to be these major hurricanes of a category 3 or to 5. And overall, even though we see it fluctuating and getting higher and lower in some seasons, overall, it appears as though within the past 5, 10, 15, 20, 25, 30 years, we're getting some of the most intense hurricane seasons. So a lot of people have said that this does correspond to an increase in global temperature, which we're going to be looking at on the next slide. So again, just looking at this data here, we see within the past 30 years or so, an increase in the amount of hurricanes that we're seeing, with the highest number being here between 2000 and 2010, which would be 2005. So go ahead and answer these questions, and then we're going to take a look at the temperature anomalies. So this is the change in temperature over the course of years compared to the average. So if we were to look again before 1940, then all of these years, with the exception of this one year over here, on average, we're a little bit lower in temperature than the average temperature, with some of the lowest temperatures being here in 1910. But then again, within the past 30 years or so, every single year has been warmer than average. And if we were to also kind of look at the trends in this bar graph, it appears as though the more recent years, there's an even greater anomaly. So if we were to look at this data combined with this data, then there is a correlation between the increased temperature anomalies and the increased occurrences of hurricanes. Now, correlation doesn't necessarily mean causation, but it is another piece of evidence that people cite as a reason for potentially more dangerous hurricanes happening. If you were to also look at this with the line graph that we looked at earlier in this unit, the Keeling curve, where we see increased amounts of carbon dioxide in the atmosphere combined with higher air temperatures on Earth, then that's another piece of evidence that people use to kind of paint this case for global climate change happening slowly but surely over the course of years. So that's it for this interactive. When we go to the next section, it's just a preview of the next activity for this interactive. So if you found this video helpful, I will see you next time.